Hello everyone. In last two reactions that I have discussed, that is aldol and parking, in both cases the nucleophile is carbon, and here also, that is in Stobbe reaction, the nucleophile is carbonyl. So different types of name reactions are there, though in all cases nucleophile is carbonyl, but depending on the type of carbonyl, that is the reagent from which we are generating the carbonyl, depending on that there will be different types of reaction. Okay, so for the last these two reactions, that is part 14, 15 and 16, you will get the link in the playlist of nucleophilic addition to carbonyl, that is in the description box. Okay, so let's start Stobbe reaction. It is also known as condensation. Now condensation means when from two small molecules we are getting a large molecule by the removal of a small molecule. Mostly it is water. So here also removal of water is taking place, and as a result we are getting CC double bond. So this is, in this reaction we are getting CC bond formation, and the reaction is going on in presence of base. One important point is here the molecule from which we are generating the carbanion is succinic ester. Succinic ester means ester of succinic acid. Here we have taken ethyl succinate because it is ethyl ester. So succinic acid is basically CO2H, then 2CH2CH2, CO2H. So it is 1,4-diacid. So the ester that we will get, that will be 1,4-diester. So this reaction is specific for 1,4-diester. Okay, the carbonyl that we will generate, it is only from 1,4-diester. And see here, these hydrogens, if we consider, only one side there is electron withdrawing group, but another side the electron withdrawing group is far from it. As a result, actually it is ester, CO2R, CO2R. That is, when the reagent we are considering in this reaction, it is the ester, not the acid. So here the acidity of these hydrogens is not very high. That is why the base that we are using, that are very strong base. Okay, we are not using any weak base, and that is the reason that the hydrogens are not very acidic. So we are using strong base. Fine. Here we are getting salt of alkylidenesuccinic ester. So one of the ester group is intact. Another ester group is converted to the corresponding carboxylate salt. The medium is basic. That is why it will remain in CO2 minus form. And then if we do acidification, it will be converted to CO2H. Fine. So the mechanism is, here the base that we have taken, Me3CO minus, that is, it is potassium tertiary butoxide. TBU means Me3C group. So this base is very strong. In presence of this base, this hydrogen will be removed. As a result, we are getting carbonyl. So this is our carbonyl. It is the nucleophile. Now this nucleophile, now it will attack the carbonyl carbon of this aldehyde or ketone molecule. So this carbonyl, it will attack negative charge over oxygen. Fine. So this is the newly generated CC bond. Now this negative charge, if it attacks this carbonyl carbon of another ester group, then negative charge will be generated over oxygen, and this negative charge, if it is pushed, then OET will be removed. Okay, so minus OET. Now we will get lactone intermediate. So this type of cyclic ester, that is known as lactone. So this CC bond is generated first. After that, the second CC bond that is generated. Now in this lactone, already ETO minus is removed, so that can act as base. So this base will capture this hydrogen. As a result, there will be formation of CC double bond, and this bond will be broken. So this hydrogen, if it is not present, suppose this hydrogen is not present, then the further step we cannot get. So that is the reason there must be 2 alpha hydrogen. That is, if we consider this ester, CO2R, CO2R. In this position, there should not be any substituents. Otherwise, we will stop, that is, the reaction will be stopped at the lactone intermediate stage. Further ring opening, that will not be possible. So the second hydrogen, alpha hydrogen, with respect to CO2R group must be present. Now finally we are getting alpha beta unsaturated. Now if you consider the CO2ET group, we can hydrolyze it. It will be converted to CO2H, and then by decarboxylation one of the CO2 group will be removed. CO2H group will be removed. In that case, we will get this type of molecule, that is alpha beta unsaturated acid. So depending on our requirement, we can change the reagent. That is, it is the main product, main Stobbe condensation product, but depending on our requirement, we can protonate it, then it will be converted to CH2CO2H, and further decarboxylation also we can do. So we can make alpha beta unsaturated ester or alpha beta, sorry, it is not alpha beta, sorry sir, it is alpha beta gamma, that is beta gamma unsaturated acid, which is also unusual. Mostly what we see, the carbonyl compound which is conjugated with CC double bond, that means it is alpha beta unsaturated carbonyl compound, whether it is acid or ester, whatever. But alpha beta unsaturated carbonyl compounds are very common. But beta gamma unsaturated acid or ester, that is unusual. So by this reaction, Stobbe condensation, we can make beta gamma unsaturated acid. So here the lactone intermediate, that is isolated for some compounds, which proves the mechanism that it is going through this type of lactone intermediate. So when we can isolate it, if the second alpha hydrogen is not present, then we can easily isolate this intermediate. And esters, where that is the point that I have just said, where only one alpha hydrogen is present, then this last step, which is mainly the irreversible ring opening. If we look at all these steps, this step, you can see there is equilibrium sign, this step. So there is reversibility, but the final step, that is irreversible. So as a result, it will drive the whole reaction towards the product formation, towards forward direction. So this irreversible ring opening is very important, which is the last step. But if the second alpha hydrogen is not present, that means if there is only one alpha hydrogen, suppose there is some substituents like this, then second alpha hydrogen will not be present. As a result, this irreversible ring opening, that is the irreversible step, which is basically driving the whole process towards forward direction, that process will be retarded. Okay, then we will not get our desired product. So 2 alpha hydrogen must be present. Now some application of this reaction. So as I have said, we can generate beta gamma unsaturated acid, and also we can, if we saturate this CC double bond, it will be converted to CH2CH2CO2H, that is propionic acid residue. Propionic means 3 carbon acid. This is 3 carbon acid, that is propionic acid. So this is CO double bond. At the site of this carbonyl, now we are getting CH2CH2COOH. So we can make, starting from cyclohexanone, we can introduce this propionic acid residue by the application of Stobbe reaction. Though some other reagents also we have to use, but here the first step will be the Stobbe reaction. Here we have taken ethyl succinate, this molecule, and base is Ne3COK, that is potassium tertiary butoxide. So this is our Stobbe product, that is with respect to this CO2, this is beta gamma unsaturated compound. And if you consider with respect to this carbonyl of CO2ET, then it is alpha beta unsaturated. Alpha beta gamma, not alpha. So with respect to carbonyl of CO2 group, it is beta gamma unsaturation, but if we consider the carbonyl carbon of the ester, then it is alpha beta unsaturated acid. Fine, unsaturated ester. Next step is, so up to this it is Stobbe product, that is the Stobbe reaction. But if we want to get this final compound, then we have to do some further steps. In presence of aqueous potassium hydroxide, that is hydrolysis of ester in basic medium, this will take place. So CO2 it will be converted to CO2H, but as the medium is basic, it will remain in CO2 minus form. So there are two CO2 minus. In the next step, here two things will happen when we will use HBr in presence of acetic acid. First of all, these two CO2 minus, it will be protonated. So now it is CO2H, CO2H. That is, now it is no longer in salt form. Now it is acid. And the second thing is, HBr will be added in this CC double bond. Now the question is, why Br is added to this carbon? Because the positive charge that will be generated at this carbon. Because when the positive charge is generated like this, it is very stable compared to if it is generated at this carbon. Now why it is so? First of all, this is tertiary carbocation, and the second thing is that if it is generated here, it is close to one of the electron withdrawing group CO2H. So from both point of view, this carbocation is more stable, so Br will be added to this carbon. Now the purpose of adding Br is that there will be removal of that is net removal of HBr. This OH bond will be broken, CO2 will be formed, that is carbon dioxide. This CC bond will be broken and there will be formation of CC double bond. Okay, that is actually the next step. So here two things are happening. One is decarboxylation and removal of HBr. So finally we are getting beta gamma unsaturated acid. And if we want this compound as our final product, then we have to stop this, stop the reaction at this step. But if we want saturated bond, not any unsaturation, if we want in that way, then we have to reduce this CC double bond. And for this reduction, we are using hydrogen in presence of copper chromite. This reagent is known as copper chromite, which is used for hydrogenation reaction. So in this way, we can introduce propionic acid residue at the site of carbonyl group. This is the first application of this reaction. The second application is synthesis of gamma keto acid. So here we have taken aldehyde, RCHO, and same succinic ester, diethyl succinate, base, and we are also using acidic condition in the final step. So that is why the Stobbe product, that is not in salt form, it is in protonated carboxylic acid form, because finally the acidification that is also done. So this is the Stobbe product. Next step, aqueous KOH, that means hydrolysis of this ester group which is remaining, and also acidification so that it is not in salt form, it is in protonated form. So now there are two CO2H group. Next we are doing bromination. So in bromination, first of all there will be formation of bromonium ion. Now bromine addition to CC double bond, that I have already discussed in some video. So for that video, if we want to get proper idea about the bromonium ion, please click on the link appearing on the screen. So bromonium ion will be formed. So this is the bromonium ion. Okay. And another bromine atom that will remain as Br minus. Now with this carbon there is two groups attached. One is CO2H, another one is CH2CO2H. So now we have written CH2COOH in this way. Okay. So here the reaction that will take place, why we have written CH2CO2H downward, because here the reaction that will take place like this CBr bond will be broken. So this proton is removed and Br minus counter ion that is already present. So here what we will get, Br will be, now this CBr bond is broken and there is CO bond formation. So this is the CO bond. So now we are getting a cyclic structure, cyclic ester. and Br is still there. So basically it is net removal of Br minus and H plus. So we can write here HBr. Fine. Now next we are using alcoholic KOH. Alcoholic KOH is used for dehydrobromination, that is removal of HBr. Now HBr, you can see with respect to this bromine there is hydrogen at alpha position. With respect to bromine, this is alpha, this is beta. So beta hydrogen is present this side, and also here we have another 2 beta hydrogen. So which hydrogen will be removed? Here this hydrogen will be removed. Now why it is so? Because if the CC double bond is generated here, then this is alpha beta unsaturated ester with respect to this carbonyl if we consider, and also with respect to this carbonyl, it is alpha beta unsaturated compound. That is why it will be more stable. So first of all there will be double bond formation. HBr will be removed in presence of alcoholic KOH, but though it is first generated, but after all this CH will be removed. So this proton, now it will come here. So now the double bond is shifted from this position to this position. And what is the driving force? Because if it is not rearranged to this new position, then further reaction will not be possible. Now this is also cyclic structure. Water molecule will attack at this carbon. As a result, this CO bond will be broken. Now this is OH, and though water is attacked, but here negative charge will be generated. So one of the hydrogen we can write here. Now this is enol structure. Enol structure, if it is converted to keto form, this is the keto form. Now in the keto form, see here with respect to this carbonyl, this carboxylic acid group, it is at beta position. This is alpha, this is beta. Or if you say that with respect to this carboxylic acid group, this is alpha, this is beta. So this is beta keto carboxylic acid. But if you consider this carboxylic acid group, it is not beta keto carboxylic acid. It is alpha, then beta, then gamma. It is gamma keto carboxylic acid. And only beta keto carboxylic acid, it is ideal for decarboxylation. So that is why this CO2, that is this CO2H group, that will be removed as decarboxylation process. So in decarboxylation what happens? This CO double bond, it will attack this hydrogen. This COH bond will be broken. CC bond will be broken, and there will be formation of CC double bond. So we will get RCOH double bond CH and CO2H. Now this is enol form. It will be tautomerized to the keto form. So finally what we are getting? CH2, CH2, CO2H. So finally we are getting with respect to the CO2H group, this is alpha, this is beta, this is gamma. So this is gamma keto acid. So starting from acetaldehyde, any aldehyde, RCOH, we can make gamma keto acid. This is the second application. Another application we will see, that is the third application, and this is the last application, which is generation of polycyclic ring. So here we have taken acetophenone, same molecule we have taken for Stobbe reaction, diethyl succinate and tertiary butoxide base. So we will get Stobbe product. As we have not used any H plus, that is final acidification, so that is why it is in salt form, CO2 minus K plus. Now we are using anhydrous HF. Anhydrous means there should not be any water, no trace of water. So in presence of anhydrous HF, this CO2 minus will be protonated first. So when it is protonated, it will be converted to COO. Here, this CO2H, it will be protonated. So this carbonyl oxygen is protonated, and that is written here. Okay. So when it is protonated, there will be attack from the benzene rings pi electron. So this pi electron, it will attack here. As a result, CO plus, this CO double bond, oxygen is positively charged, it will be neutral. And positive charge will be generated at this carbon. Oxygen is neutral now. Now this CH, it will be removed as minus H plus. So it is minus H plus, then plus H plus. So this hydrogen, it is removed. We are getting aromaticity back, and one of the OH will be protonated. Now this protonated OH2, protonated OH, now it will be removed in the form of water. And in the right hand side ring, there will be aromaticity generation. So this CH bond, it will make CC double bond and water will be removed. So it is removal of H plus and also removal of H2. And this is the final molecule. So starting from one benzene ring, now there is two benzene ring. Fine. So this portion is basically coming from acetophenone, and this part is coming from diethyl succinate, and it will remain in the ester form because we have not used any water here. We have used anhydrous HF. But if we want to make the as it is, that is, we want to make the acid, then we have to hydrolyze this ester, and if we do not want this CO2H group, then we have to remove it. So different other compounds we can make, but the main thing is here, starting from one benzene ring, now we have obtained two benzene ring. So this is polycyclic ring generation, and this is the last application of Stobbe reaction. In the next video, another reaction will be discussed. There also the nucleophile is carbon. Just like here, that is in case of Stobbe, aldol, parking, we have seen nucleophile is the carbon. In the next video, the reaction that I will discuss, there also the nucleophile is Carbanion based. So under Carbanion based nucleophile, there are actually different type, variety of reactions. Fine. So if you find the video helpful, please like, share and subscribe. I'll meet you in the next video. Important links you will find in the description box. Thank you for your time.